Hello, everyone. Welcome to Can.Do.So. This is ready. Let's continue our GV900 class. In this lesson, we will learn confidence intervals. And first, note the package we use in this lesson. This is tidyverse, and this one open intro will help us to draw the plot. And the car data is a data package where we use BEPS dataset. So next lesson, we have learned that the standard error of a sample is calculated as follows. The standard error can be calculated by standard deviation divided by square root of degrees of freedom. And this is standard deviation. And with standard error, we can calculate the confidence interval. Confidence interval is a range of values that is likely to contain the population parameter with a certain degree of confidence. So the 95 confidence interval is calculated as follows. CI is short for CI is is confidence interval and equals to y bar is the mean of the sample and plus or minus 1.6 times standard error. So we know the mean of the sample, standard error of sample, but what is 1.96? And why it's 1.96? So let's go to the R. We have learned in previous course that we can find out the critical value of the of certain probabilities. In this case, we find out the probability of 0.9797. So in this case, it's 1.96. So that's why we use 1.96. And what does this mean? We can say from this picture that we can see from here. In this case, in the middle, which is 95%, and as this here is 0.25. No, it's 0.5%, 2.5%, and here is also 2.5%. And this plus this is 5%. So the other part is 95%. And this value is here is close to -2. So this value is minus 1.96, and this value is 1.96. Here we use a standard normal distribution. So this is centered around the zero with standard deviation with 1. So we use close to 2 standard deviation. If you still remember, you remember that 98%, 95%, and 99.7%. So this is closely 1, 2, and 3 standard deviation. So if we want to calculate the 99 confidence interval, we can use 2.58%. So why 2.58%? So the similarly, we can use this Q norm function to find out the this value is 2.56. In this case, which means in the middle is 99%, and here is 1%, 0.5%, and 0.5%. So this value here, critical value is 2.58, and here is minus 2.58. 58. So now we use a example to actually calculate a confidence interval. We use the BEPS data to calculate it. Here, we assume that the whole data set is the population. So which means the 1,525 data set is the population. Let's go to the here. So we take this 1,525 entries as the population. And so we can find out the population mean and the standard deviation of age, which is 54 and 15.7. Then we take a sample with the size of 100. So we randomly choose 100 observations. If you still remember this means take 100 sample, and this one's to find the mean of the sample, the standard deviation of the sample, and the standard error of the sample. Okay. So which is this? Okay. It's 53, 15, and 1.757. So the 95% confidence interval is calculated as follows. So first we find out the lower cut. So use the sample mean minus 1.96 and times sample standard deviation. And upper cut is plus. So we get the 95 confidence interval is from 51 to 57. In this example, we say that So in this example, we say that we are confident, we are 95% confident that the interval, this interval covers the population mean age, which is true in this case. Sorry for this is true as a typo, because the population mean age is 54, so it's in this interval. You can see that the population mean is 54, so has been covered in this one. And what does it mean? So in this case, which is this is sample mean. Sample mean is here, like we have find out, and the confidence interval is here from 51 to 56 around, and covers the sample mean, which is 54 here. The true population mean, it's here. So if we want to find out the 99% confidence interval, it's the same. We just change the value, the critical value to the 2.58. This score value is to 2.58. Then it's 49 to 57. You can see that this one is wider than this one. Is wider than 49 to the left and 57 to the right, so which is wider. And you can see that this much wider than this one. This one is wider. In this example, we say that we are 99% confident that the interval covers the population mean age, which of course is also true in this case, because the 99% confidence interval is wider than the 95% confidence interval. So if the narrow one, 95% confidence interval covers the population mean, then the wider one, of course, covers as well. However, in this case, we assume that the population mean age is 54 because we use the data set as the population. But the data set actually is just a sample mean of the whole population, because the whole population is should be tens of millions. So we don't know the population mean. So now let's estimate the population mean age with the sample. Okay, so this time we take the whole data set as a sample. So which is, go back to here. And now it's 54, standard deviation is 15, and standard deviation is much smaller because the sample size increased to 1,525. In this time, we use the capital S to differentiate with the 100. So the 95% confidence interval is calculated as this. It's 95% confidence interval is 53 to 54, which is much narrower. In this case, it's much narrower, you see. In this example, we see that we are 95% confident that the interval covers the population mean age. But in this case, we don't know the population mean age, so we cannot say whether the interval actually covers the population mean age or not. But we are 95% confident it does. Still, there are 5% chance that it does not. Normally, we use 95% confidence interval, but we can also use 99% or 90% confidence interval. And which level to use depends on the situation, depends on the project, the research target, or the something like that. Generally, if we want to be more confident but less accurate, we use 99% confidence interval. And if we want to be less confident, if we want to be more accurate and less confident, so we use 90% confidence interval, which means confidence interval is a trade-off between confidence and accuracy. It's like a archer aiming at a target. You see? The archers will say that he is 100% or maybe 99% confidence interval that his arrow will target the whole board, the whole board. He's very confident. But if he say how confident he can target the bullseye, what do you think? I think he might not be so. They might not be so confident. Maybe 90%, or if it's a very good, maybe they will be 95%. If they are not so good, maybe they are 85% or confident that they will target the bullseye. So that's the idea. If they are more confident, so which means they might not be so accurate to the bullseye. If they are accurate, they may not be so confident. Okay. And so confidence interval, let's recap. Confidence interval is a range of values that is likely to contain the population parameter with a certain degree of confidence. And the 95% confidence interval is calculated as follows. And in this lesson, we assume that we know the population standard deviation. So we use z-score to calculate the confidence interval. So this one is z-score. However, in t-test lessons, we will learn how to calculate the confidence interval when we don't know the population standard deviation. So if we don't know, we use the t-test. Okay, that's all for this lesson. Thank you for watching. Please leave a message below to help me to improve this channel, and see you next time.